Okay, guys, we're going to look at Are You Smarter Than a Mythbuster? The quote that we have here is shoot for the moon, and if you miss, you'll land, or you'll still be among the stars. When we're looking at this, our learning objectives, our goals that we're trying to accomplish in this video, to understand the factors that affect the range of a horizontally fired projectile. So we want to see what happens and what factors actually contribute to a horizontally fired projectile. So we'll be in 2D motion here. Number 2 is recognize the importance of flight time in solving multi-dimensional problems. So we're going to look and see what factor time plays in the x and the y axis. And number 3 is solve for an unknown variable in either the horizontal or the vertical direction, given information in the other. So what we're going to do is we're going to be given a portion of the problem, and we'll have to look at the x and the y axis to figure out what we're solving for, and manipulate our variables to either solve for something in the x or something in the y. Okay, we're going to look here, we're going to look at some Angry Birds, and we're going to look and see what path does the projectile take. So in looking at the video, what we should have seen is the Angry Birds as they were shot, in the projectile. Basically, they're the projectile. As we saw them, they create this type of shape. And what we call this is, we call this parabolic motion. It creates a parabola. And so we see this motion throughout projectiles, and it depends on the angle at which we fire it. So we saw some of the Angry Birds went like this, and some of them went up really high and then came down, but they all had the general shape of having a parabola. And what we see is that parabola is caused by two different things acting upon it. We have both motion in the x and motion in the y-axis. Now, the main thing with projectiles, the most important thing about it is time. Okay, what we'll see is that time is going to be the same for us in the x and in the y-axis. Okay, the time the projectiles are in the air does not depend on the horizontal velocity of the object. So if I was to take what we did yesterday with our marbles and everything else, what we should have seen is that the marble that we dropped straight down and the marble that was shot horizontally, they're going to have the same flight time, okay? Because the horizontal velocity, that has no effect on it. So because it's falling straight down, and because this is basically doing the same thing, the one that was shot horizontally, what we see is that it's going to have the same time. Okay, the time the ball falls should equal the time the ball moves horizontally. So as it moves horizontally, it's going to have the same amount of time to move horizontally it does for the ball to fall straight to the ground. Okay, time is going to be the key in projectiles. We're going to use time, and what we're going to see is time is going to be the same for us in the y-axis and in the x-axis, which is very, very important when we're solving problems. Now, a few things about horizontal velocity. There are no forces acting horizontally on the ball. We're assuming that there's no air resistance. Okay, there's no air resistance acting on it, and that it has no forces acting on it horizontally. So basically, our horizontal velocity, there can be no horizontal acceleration. So if there's no acceleration, all we're going to be using is a constant velocity equation. So if we look here, this is the only equation that you can use in the x-axis. And I'm making a big note of this. That's the only equation you can use. You can use your average velocity, and basically we're going to use our constant velocity equation, where it just equals our distance all over our time. And so we can measure here, we know our distance, our time, it's going to be a constant velocity in our x-axis. Now vertically, Gravity is a force acting on the ball downward, so there's always gravity. So the vertical component will always have acceleration, which equals 9.8 meters per second squared, and it's negative because it's pulling it downward. There must be an acceleration vertically, so there will always be gravity, and vertical velocity changes throughout. So as it moves up and down, it's going to change throughout. Key thing here, if that applies. So we look in the x-axis and we're just using the constant velocity equation. In the y-axis, we have all of our motion equations, and we have to apply if that to know which one to use in the y-axis. So x-axis, constant velocity, one equation only. But in our y-axis, what we're going to see is we have if that. So when we break up the variables, we separate the given into horizontal and vertical. Okay, so horizontal being our x-axis and vertical being our y-axis. Now what we're going to see is that in our horizontal and our x, we have velocity, we have distance, and we have time. That's all that we're going to have. Remember that time is going to be the same. It's the same in the y-axis and in the x-axis. So they're both the same. So if I have my time for the horizontal component, I also have my time for my vertical component. Now, but remember, in our vertical component, we use if that. So we'll have initial velocity, final velocity, we'll have distance, we'll have acceleration. One thing about acceleration, remember that it's always going to be negative 9.8 meters per second squared. We're always going to have gravity unless we're not on Earth. Okay, but make sure that we pay attention to that. Okay, so let's look at example A1. It says that we have a 5 centimeter ball rolls down a ramp along a flat frictionless table through a photo gate and then off the ledge of the table as shown. The ball lands 1.4 meters from the edge and 0.8 meters of a 0.8 meter tall table. What will the reading on the photo gate be? So there's a lot of things here that we have to take into consideration. Number one, it is asking us what is the reading on the photo gate. So we're going to be looking back and trying to figure out what the time is on the photo gate. To do that, okay, what we're going to have to figure out is we're going to have to figure out the velocity that left the table. Now, one thing that we have to take into consideration here is that there's two things acting. We have our x and we have our y motion. Okay, so it's write down all the things that we're going to have in our x-axis. So on our x-axis, we know that we have a distance of, or sorry, not in our x-axis, that'll be in our y, we have a distance of 0.8 meters. That's how high the table is. We always have acceleration. It is going to give us our 9.8 meters per second squared. And in this case, since it rolled off the table onto the ground, it's going to have an initial velocity of 0. Okay, so it's going to have an initial velocity of 0. Now, normally with these problems, what you're going to see is you're always going to be solving for time, because what's the same in the x-axis? Well, it's always going to be time. So time is normally going to be what you have to solve for first, because when we're looking at this, we know that in the x-axis that it's going to be constant velocity. So if I know the time that it took the ball to hit the ground, I can use my time that it took to hit the ground and the distance that it traveled, because I have a distance of 1.4 meters that it traveled in the x-axis. If I know the time, I can find the velocity, and that velocity will help me figure out the velocity at the top of the table is going to be the same as the velocity that it hit the ground with, and so I can figure out the time on the photo gate. So let's start with that. Let's do our if that. We see that this equation does what we're looking for. We have distance, acceleration, initial velocity, and time. So it's not going to have final velocity. So we're going to use our equation where we have our distance equals our initial velocity times time plus 1/2 a/t squared. That's the equation that we're going to use. Okay, our initial velocity is 0, so we're going to have our distance equals 1/2 a/t squared. Okay, we're solving for time here, so we're going to end up with an equation of time is going to equal the square root of our distance all over, and I like to keep 1/2 as 0.5a. Okay, so plug in our variables here. What we're going to see is we're going to have 0.8 meters all divided by 0.5 times our 9.8. Okay, and this is going to give us, let me put my 8 right there. This is going to give us a number of our time, and our time is going to be right around our 0.4041, and that's our time. And that's our time in our x or our y-axis, which is also the time in our x-axis. So the only thing that we need in our x-axis, the only equation that we can use in our x-axis is velocity equals distance all over time. Well, we know what our distance is. It traveled 1.4 meters in 0.4041 seconds. Okay, and what we see here is we're going to get a velocity of 3.464 meters per second. Okay, that's our velocity in our x-axis. Okay, and that's the velocity that traveled through the photo gate. Now the trick here is a lot of people would stop right here, but remember, what does the photo gate measure? A photo gate measures our instantaneous velocity, and that's what we have. What the problem's asking for is the time on the photo gate. So we know that our velocity is going to equal our distance all over our time, and we know that that is going to be our velocity. Our distance is going to be the diameter of the ball, which is 0.5 centimeters. And so remember, convert 5.0 centimeters, convert that into meters, which is 0.05 meters, and solve for time, and you should get an answer right around 0.014 seconds, and that will be the time on the photo gate. Example A2. Now it says a plane is tasked with dropping emergency supplies to a cruiser stranded in the Gulf of Mexico. The plane is moving horizontally with a velocity of, and it gives us that velocity, 140 meters per second, and an altitude of 2,000 meters above the ocean. What horizontal distance away from the cruise ship should the plane release its supplies to land on the deck of the ship? Now, I'll start you off on this problem and see if you can't get the answer. The one thing that we should write down, the first couple things that we do have our horizontal velocity. So remember, on all problems like these, break it up into x and into y. Okay, now we're looking at this, our horizontal velocity, so our velocity in the x direction is just going to be 140 meters per second. Okay, we have that. We have the altitude, which altitude was going to be our distance in the y, is 2,000 meters. The other thing that we should have, we always have, is its gravity, acceleration, 9.8 meters per second squared. We also know that since it's flying horizontally, it's going to have an initial velocity in the y direction of 0 meters per second. Okay, and it wants to know at what horizontal distance away from the cruiser should the plane release its supplies. So basically what's going to happen is it's traveling here, it'll release them, and it'll travel down. Now the main thing that we have to understand is that it's going to travel, it's going to take a certain amount of time for it to fall. So you're going to be looking for the time that it takes to fall, and then we're going to relate that back to finding the distance in the x direction. So solve for time and then bring it back to the x and solve for distance, and you should be able to get your answer. Now let's look at the next example. And on this one, kind of the same principle. A rock is thrown at 20 meters per second off a cliff, landing 84 meters away. How tall is the cliff? We see that it gives us that is going to be our velocity in the x. That is our distance in the x. Remember, we know acceleration. We know what the initial velocity is in the y. Work this one out, and we should get an answer right around 86 meters. Work that one out and see if you can't get it.